Task 2, solving systems of linear inequalities by graphing. Solving a system of inequalities means finding the ordered pairs that satisfy all of the inequalities in the system. Your solution for these types of problems is going to be a shaded area on the graph. So when you solve a system of inequalities, there are a couple of steps you can follow. The first thing is you're going to graph each inequality. This means graphing a line. So you're going to use what you learned about graphing lines from task 1 in this task. Then you're going to shade the correct area for each. More on this a little bit later. Then you're going to identify the region that is shaded for all of the inequalities. That's the solution of your system. A couple of things to remember about inequalities. If the inequality symbol is less than or greater than, then you're going to connect the points on the line using a dashed line. If the inequality symbol is less than or equal to or greater than or equal to, you're going to connect the points on the line using a solid line. If the inequality symbol is less than or equal to, you're going to shade below the line. And if the inequality symbol is greater than or equal to, you're going to shade above the line. So let's try an example. Let's graph this first system. The first equation says y is greater than or equal to 2x minus 3. That inequality has a y-intercept at -3. So I'm going to plot a point at -3 on the y-axis. My slope is 2. But we want to rise over run, so I'm going to think of my slope as 2 over 1. We can make any number a fraction by putting it over 1. So I'm going to go up 2 units and over 1. Up 2 units and over 1. Again, I'm going to put more points on this graph to fill it up. I'm going to go the other direction. Now my inequality is greater than or equal to. That tells me that the points on the line are part of the region, are part of the solution. So I'm going to use a solid line. And for this graph, because it's greater than or equal to, I would shade above the line, which means I'm going to shade on this side. I'm going to switch colors. And let's do y is less than -x plus 2. That has a y-intercept of +2 and a slope of -1. So that means I got to go down 1 and over 1 to the right. And I could go up 1 and over 1 to the left. Now, that inequality is just less than. It doesn't have the equal to part. So that tells me that the points on the graph, or on the line, are actually not part of the solution. So I'm going to use a dotted line, not a solid line. Because it's less than, I'm going to shade below this line, which means this direction. Where do those two regions overlap? Right here. So where the yellow is would be your solution region. Let's try another. Let's add on a couple more inequalities and have to do a little bit more work. If you want to get some colored pencils out, I always recommend my students do that to keep these different lines straight or separate. I have to do some work with this first inequality. I have to move the 2x over which will give me negative y is greater than or equal to negative 2x minus 1. Now this example gives me a perfect time, is the perfect time for me to remind you when you're solving inequalities and I have to divide both sides by a negative number, like I'm doing right now by dividing by -1, that inequality symbol has to switch. So instead of greater than or equal to, it switches to less than or equal to. And my inequality becomes y is less than or equal to 2x plus 1. I'm going to go ahead and graph that. Y-intercept of 1, slope of 2, so up 2 and over 1. Up 2 and over 1. Can go the other direction as well. Less than or equal to, so a solid line connecting those dots. It's less than, so I'm going to shade below the line for that one. Next equation, I got to move that x over, so I'm going to get 4y is greater than or equal to negative x plus 4. And I have to divide by 4. Now, I'm dividing by a positive 4, so I don't have to worry about doing anything with that inequality symbol. I'm still going to have y is greater than or equal to negative 1/4 x plus 1. I'm going to go up to 1. So those first two inequalities share the same y-intercept. And my slope is negative 1/4, so I'm going to go down 1 and over 4 units. Down 1. Oh, I can't quite reach there, so I'm going to go up 1 and over 4 back from the y-intercept. That's also a greater than or equal to, so I can use another solid line for this line. This one's greater than, so I'm going to shade above for this line. Now, if these were my only two inequalities, I'd be shading in the upper right-hand corner of this graph, because that's where the two blue pieces overlap. But I still have two more equations. I have x is greater than 0. X is greater than 0. Anytime I have x in just a number, like this example, it's a vertical line. And it's going to be going through 0 on the x-axis. And it's simply greater than. So I'm going to use a dotted line, not a solid line. And it's greater than, so I'm going to shade above that line. Graph might be getting a little messy, it's okay. Different colors are helpful in this case. The last inequality is y is less than or equal to 4. Anytime I have an inequality like that where it's y and then a number, that's a horizontal line. It's going through 4 on the y-axis. So this last line will be a horizontal line going through 4 on the y-axis. It's less than or equal to, so this is going to be a solid line. And it is less than, so I'm shading below. Now, this is getting kind of messy, but I want to see where do all 4 of those colors overlap. And it's going to be right here, in between the green and blue,